Good day, everyone. This is Mamel, and welcome to Chapter 2. I'm sorry I had a typographical error here. It's not Lesson 2, but Chapter 2. Today, we begin exploring the intellectual revolution, which is a transformative period that reshaped how humans understand the world and their place in it. So, by the end of this lesson, students should be able to, number one, discuss the paradigm shifts that occur throughout the history. Second, explain how the intellectual revolution changed the way humans see the world. And number three, describe the technological advancements that emerged during the information age. These outcomes will guide our discussion and help us connect historical shifts in thought to the innovations shaping our lives today. So let's dive deeper into each of these in the next slides. Now that we've outlined the learning outcomes of this lesson, let's take a moment to reflect and engage with some key questions that will guide our thinking throughout the discussion. First, do you agree that intellectual revolutions help transform society? If yes, how? This question invites us to consider the real-world impact of ideas, how shifts in thought can ripple through institutions, cultures, and everyday life. Second, who were the remarkable people that gave their contribution during the intellectual revolutions? In here, we'll explore the thinkers, scientists, and reformers who dared to challenge norms and expand the boundaries of human understanding. And finally, if we are in the information age, what impact does it give to society? This question brings the conversation into our present movement. How do today's technologies and information systems shape the way we live, learn, and connect? Keep these questions in mind as we move through the lesson. They are not just prompts, they are invitations to think critically, connect ideas, and see the relevance of intellectual revolutions in our own lives. So, in the previous chapter, we explored how historical antecedents influenced the development of science and technology. We learned that most discoveries and inventions were driven by human needs and desires, where the solutions created in response to the demands of the time. And so these innovations weren't just about convenience. They were reflections of what people needed to improve their lives. But there were also moments when science and technology didn't respond to society. They reshaped it, okay? And that brings us to the intellectual revolution. This period marked a significant shift in human understanding, and therefore advancements in human and technology challenged long-held beliefs and introduced new ways of thinking about the world. In this chapter, we'll examine how science and society interact. We'll also build on what we discussed earlier in Chapter 1 and look more closely at how knowledge evolves, not in isolation, but through its relationship with culture, politics, and, of course, human experience. Let's now take a closer look at one of the most groundbreaking moments in the history of science, the Copernican Revolution. This was a turning point not just in astronomy, okay, but in how humanity understood its place in the universe. In the early times, people asked simple but profound questions. What causes day and night? What are those glowing bodies in the sky, like stars, moons, and planets? These questions reflected a deep curiosity about the cosmos. The invention of the telescope was a game changer. It allowed people to observe outer space more closely. But more than that, it sparked a hunger to know what was really out there, to move beyond myth and tradition and toward evidence-based understanding. The Copernican model proposed that the Earth was not the center of the universe, but rather that it revolved around the sun. This challenged centuries of belief and marked the beginning of a scientific revolution that would ripple across disciplines. As we continue, we'll see how this shift in perspective laid the foundation for future intellectual revolutions and how it continues to shape the way we think today. Before the Copernican model challenged tradition, the dominant belief was the dominant belief was geocentrism. Geocentrism is the idea that Earth was the center of the universe. This model placed our planet at the heart of all celestial motion, with the sun, moon, and visible planets revolving around it. Many Greek philosophers and early intellectuals tried to explain the movement of heavenly bodies. They believed that planets moved in perfect circular paths and that these motions were responsible for phenomena like day and night. This belief wasn't just scientific, it was deeply cultural and spiritual. The Earth centered model, or the geocentrism model, aligned with religious views and reinforced the idea that humanity held a privileged position in the cosmos. But as observational tools improved, especially with the invention of the telescope, these ideas were challenged. The geocentric model couldn't fully explain the irregular movements of planets, leading thinkers like Copernicus to propose a radical alternative, which is called heliocentrism. And we will discuss heliocentrism later on. So, this shift from geocentrism to heliocentrism wasn't just a technical correction, it was a revolution in thought. It marked the beginning of modern astronomy and reshaped how we understand our place in the universe. To understand how revolutionary the Copernican model was, we need to look at what it replaced. One of the most influential figures in early astronomy was Claudius Ptolemy, a philosopher and astronomer whose ideas shaped scientific thought for centuries. Ptolemy proposed that the Earth was the center of the universe and that the sun, moon, and planets moved in circular paths around the Earth. This concept, known as geocentrism model, was widely accepted and even celebrated as one of the greatest discoveries of its time. Ptolemy's model, the geocentrism, helped explain observable phenomena like the rising and setting of the sun and the occurrence of day and night. It also aligned with both philosophical reasoning and religious beliefs, reinforcing the idea that Earth, and by extension humanity, was at the center of all creation. But as we'll see, this Earth centered view would eventually be challenged by new observations and bold thinkers. The Copernican revolution didn't just introduce a new model, it also questioned the very foundations of how people understood the universe. So let's move forward and explore how Copernicus reshaped this narrative and what it meant for science, society, and the evolution of human thought. Let's now turn to the figure who sparked one of the most transformative shifts in scientific thought, Nicolaus Copernicus. In the 16th century, this Polish mathematician and astronomer boldly challenged the long-standing Ptolemaic model. Instead of placing Earth at the center of the universe, Copernicus proposed a radical idea that the Sun, and not the Earth, is at the center of the solar system. Therefore, this concept is known as heliocentrism. So let me repeat that. In heliocentrism model, the Sun is at the center of the solar system and not the Earth. And so at that time, this idea was deeply unsettling. It contradicted religious teaching and cultural beliefs that positioned Earth as the first and most important creation. Many people rejected it outright, not because of lack of evidence, but because it disrupted their world view. But Copernicus' model laid the groundwork for future discoveries. The Copernicus model, which is the heliocentrism, opened the door for astronomers like Galileo and Kepler or Johannes Kepler to refine our understanding of planetary motion and challenge the boundaries of accepted knowledge. This moment in history reminds us that intellectual revolutions often begin with discomfort. They ask us to rethink what we believe, and in doing so, they move us closer to truth. Okay, so next slide. We have here, as Copernicus introduced the heliocentric model, he wasn't just proposing a new scientific idea, he was also challenging centuries of belief. And so his teachings contradicted religious doctrine, and for that he was even persecuted as a heretic. But over time, astronomers began to realize the strength of the heliocentric model. The heliocentric system simplified planetary motion and resolved inconsistencies that the geocentric model couldn't explain. And so instead of complex loops and epicycles, the heliocentric model offered a more elegant solution, such as planets orbiting the sun in elliptical paths. This shift didn't just improve astronomical calculations, it also transformed how people understood their place in the universe. Therefore, Earth was no longer the center of everything. It became one of many planets orbiting a star among countless others. This realization was humbling, but it also opened the door to deeper inquiry and discovery. The Copernican revolution reminds us that progress often begins with discomfort. It takes courage to question the familiar and vision to imagine something greater. As Copernicus' heliocentric model gained traction, other scholars began to build upon his work. New studies emerged, offering further evidence and refining the theory. Slowly, the scientific community and eventually the public began to accept this new understanding of the cosmos. This shift marked the birth of modern astronomy. So it wasn't just a change in planetary models, it was a transformation in how knowledge was pursued. Observation, experimentation, and evidence became the foundation of scientific inquiry. And this era gave rise to what we call now the scientific revolution. It reshaped the society's thoughts and beliefs, challenging tradition and encouraging a more critical, investigative approach to understanding the world. Therefore, we could say that the Copernican revolution reminds us that the intellectual courage can change the course of history. It's a powerful example of how science and society evolve together, sometimes slowly, sometimes radically, but always in pursuit to deeper truth. So, to truly appreciate the magnitude of Copernican revolution, we need to look at the two thinkers who stood on opposite ends of this intellectual shift. We have on the left side Claudius Ptolemy and on the right side Nicolaus Copernicus. Ptolemy was a Greco-Roman philosopher and astronomer. His geocentric model placed Earth at the center of the universe, and for centuries it shaped how people understood the cosmos. His ideas were deeply rooted in tradition and aligned with religious teachings of the time. On the other hand, Copernicus, he challenged the view of Claudius Ptolemy. His heliocentric model placed the sun at the center, with Earth and the other planets orbiting around the sun. So this wasn't just a scientific proposal, it was a radical reimagining of humanity's place in the universe. These two figures represent more than just competing models. They symbolize a shift from inherited belief to evidence based inquiry, from looking up with reverence to looking out with curiosity. As we move forward, we have to keep in mind that revolutions in thought begin with a single question and the courage to answer it differently. Let's now shift our focus to another groundbreaking moment in intellectual history, the Darwinian Revolution. Darwinian revolution was one of the most controversial scientific revolution of its time, and its impact continues to shape biology, ethics, and even social thought today. In the year 1859, I'm sorry, it was 1859, Charles Darwin was an English naturalist, biologist, and geologist, published his landmark book titled On the Origin of Species. In it, he introduced the theory of evolution. Theory of evolution is a bold and transformative idea that challenged traditional views on life and creation. Darwin proposed that populations evolve through a process called natural selection, where individuals with best traits suited to their environment are more likely to survive and reproduce. Over time, these traits become more common, shaping the course of species development. This theory didn't just explain biological diversity, it also redefined how we understand life itself. It also suggested that change is constant, that adaptation is essential, and that survival depends not on perfection but on fitness. So I think you're very familiar with survival, survival with the fetus. Okay? So as we continue, we'll explore how Darwin's ideas were received, resisted, and eventually embraced, and how they spark new ways of thinking about nature, humanity, and progress. Let's continue our discussion on Darwinian revolution. Darwin's theory didn't just explain how species change, it also introduced a powerful idea that organisms adapt to their environment over time, and therefore gradually evolving traits that make them more competitive for survival. This process, known as evolution, emphasized that change is not random. Evolution is shaped by natural selection. Organisms that are better suited to their surroundings are more likely to survive, reproduce, and pass on their traits. So, this is according to the theory of evolution, which was shaped by natural selection. However, Darwin's ideas were not universally welcome. Why? Because many people saw his theory as a direct contradiction to religious teachings, particularly the belief that life was created by a divine being. The suggestions that human evolved from earlier forms was especially controversial. Darwin was labeled as a myth breaker, as shown in this book cover, Charles Darwin, Destroyer of Myths. His work forced society to confront difficult questions about origin, purpose, and identity. Despite the controversy, Darwin's theory became a cornerstone of modern biology. It reshaped the scientific inquiry and opened a new pathways for understanding life, not just as it is, but as it changes. As Darwin's theory of evolution gained attention, it entered a world where most people accepted the biblical account of creation. So this created a deep divide between those who saw evolution as a scientific explanation for life and those who viewed it as a direct challenge to religious beliefs. So the controversy sparked intense debate. For many, the idea that life evolved through natural process seemed to contradict the belief in divine creator. So the tension between science and religion became one of the defining features of this Darwinian revolution. But over time, perspectives began to shift. So scholars, theologians, and scientists explored ways to reconcile Darwin's theory with spiritual beliefs. Eventually, many came to understand that science and religion need not to be in conflict. They can coexist. Okay, so science and religion can coexist, offering different lenses through which to view life and its origin. The Darwinian revolution wasn't just about biology, it was about belief, identity, and the courage to question. It challenged society to think more deeply, and it also opened the door to a more nuanced understanding of the truth. As we move forward, we'll continue to explore how intellectual revolutions like this one reshape not only knowledge but the very foundations of culture and thought. To better understand the impact of Darwin's theory, let's take a look at the evolutionary journey of humankind. This timeline illustrates how our species gradually developed over thousands of years, physically, cognitively, and socially. We begin with Australopithecus around 350,000 years ago. These early hominids walked upright and stood about 4 feet tall, so a major step in human mobility and posture. Then came Homo habilis, known for their ability to speak and use basic tools. At 5 feet tall, they marked a leap in communication and problem solving. Then we have Homo erectus. Homo erectus discovered fire and used stone tools, so the key innovations that shape survival and community life. And later we have Homo neanderthalensis. Okay, Homo neanderthalensis formed social groups and crafted specialized tools showing signs of culture and cooperation. And finally, we arrive at Homo sapiens sapiens, our species. So emerging around 40,000 years ago, we began using art, bone tools, and symbolic communication. This stage reflects not just survival, but creativity and meaning making. This progression is a powerful illustration of Darwin's theory in action. It shows how adaptation, environment, and innovation shape the human story one step at a time. So now let's turn to another major intellectual shift, the Freudian Revolution. This revolution didn't take place in the stars or in biology, but in the human mind. It redefined how we understand behavior, emotion, and identity. In earlier centuries, psychology was considered a branch of philosophy. So psychology was considered more of an art than a science. So it was speculative, abstract, and often lacked empirical grounding. But in the late 19th century, in the name of Sigmund Freud, a physician and neurologist, he introduced a radically new approach, psychoanalysis. His theory proposed that human behavior is deeply influenced by unconscious drives, childhood experiences, and internal conflicts. So Freud's work shifted psychology from philosophical speculation to clinical practice. He introduced concepts like the id, ego, and superego, repression, and dream analysis. So these ideas that still shape psychology, literature, and even pop culture today. So the Freudian Revolution reminds us that intellectual breakthroughs aren't always about what we can see, they're often what we have overlooked. So Freud or Sigmund Freud taught us to listen to the mind's hidden voice. So next we have psychoanalysis. So psychoanalysis is the approach aimed to explain human behavior by exploring both conscious and unconscious influences such as emotions, memories, and internal conflicts that shape how we think and act. Freud believed that personality is composed of three interacting forces: the id, which represents instinctual desires, and then we have ego, which mediates reality, and the superego, which reflects moral standards. These elements are often in conflict, influencing behavior in complex ways. However, Freud's ideas were not universally accepted. Many scientists criticize psychoanalysis for lacking empirical evidence and experimental validation. To them, it felt more philosophical or even mystical than scientific. However, despite this criticism, Sigmund Freud's work opened new pathways for understanding mental health, therapy, and the human experience. It also challenged the boundaries of science and invited deeper conversations about what it means to be human. The Freudian Revolution reminds us that intellectual progress isn't always linear. Sometimes it begins with bold ideas that provoke debate, and in doing so, push the field forward. So let's just have a breakdown of Freud's three-part model of personality: id, ego, and superego. So, id, when we say id, this refers to the primal the instinctual part of the mind. So id operates on the pleasure principle. So when we say pleasure principle, this means seeking immediate gratification of basic drives like hunger, like sex, and like aggression. For example, we have a child sees a cake and grabs it without asking, so driven purely by desire. So this is an example of id. Or another example, we have an adult feels intense road rage and wants to yell or retaliate immediately. Then how about ego? So ego is the rational decision-making part of the human mind. So ego operates on the reality principle. So reality principle, this means mediating between the id's desires and the constraints of the real world. For example, we have you're hungry during a meeting, but instead of interrupting to eat, you wait until it ends and then grab a snack. So the ego balances impulse with appropriateness. Then last, we have the superego. This is something to do with the moral conscience. Okay? So superego represents internalized societal norms, values, and ideals. It judges actions and generates feelings like guilt or pride. Muna gitawag siya og moral conscience. For example, you're tempted to cheat on an exam, but your inner voice reminds you it's wrong and you'd feel ashamed. And therefore, you choose not to cheat even if no one would find out. Okay, so despite the criticisms and skepticism surrounding his work, Sigmund Freud remained committed to refining his theory. He believed that psychoanalysis wasn't just a framework for understanding behavior, it could be a clinical method for treating mental disorders. Freud developed techniques like free association, dream interpretation, and talk therapy to uncover unconscious conflicts and help patients gain insight into their emotional struggles. This method laid the foundation for modern psychotherapy. So over time, as more practitioners applied psychoanalysis in clinical settings, the public and scientific community began to recognize its value. What was once dismissed as speculative gradually earned its place as a legitimate field of study. So the Freudian revolution transformed psychology from philosophical reflection into a therapeutic science. It taught us that healing begins with understanding, and that the mind, though complex, can be explored with care and curiosity. So as we conclude this segment, we have to remember that intellectual revolutions don't just change ideas, they also change lives. So Freud's legacy continues to influence how we think, how we feel, and care for one another. As we wrap up this lesson, let's take a moment to reflect on the revolutions. We've explored the Copernican Revolution, Darwinian Revolution, and Freudian Revolution. Each one challenged the status quo, reshaped how we understand the world, and left a lasting impact on both science and society. So these theories didn't just transform academic disciplines, they also molded beliefs, values, and worldviews. They show us that science is not separate from humanity. It's deeply intertwined with how we live, think, and evolve. So whether it's astronomy, biology, or psychology, each revolution began with curiosity and courage. And through research and experimentation, people continue to deepen their understanding of the universe and themselves. So intellectual revolutions reminds us that knowledge is dynamic. So knowledge grows, it can shift, and it can also invite us to question. So in doing so, it empowers us to see the world not just as it is, but as it could be. So that brings us to the end of our journey through the Copernican, Darwinian, and Freudian revolution. So these three powerful shifts that reshape how we understand the universe, life, and human mind. These revolutions remind us that knowledge is never static. So knowledge could evolve, knowledge could challenge, and knowledge could empower. So as future thinkers, scientists, and leaders, you carry the torch of inquiry forward. So keep asking questions, keep exploring, and most importantly, stay open to ideas that push boundaries and expand perspectives. So thank you for being part of this lesson. So good luck in your studies, and may your own intellectual revolutions be just as transformative.